In order to graph logarithmic functions, we need to know a few things about these types of functions. The first of which is what we call the vertical asymptote of the graph. If we look over on the left side where the graph is, we can see that this graph on the left side of the graph is going fairly vertical and will continue to do so as it approaches the line x is equal to -1. That's what we call our vertical asymptote. It's a boundary line that this graph is never going to cross. And as we look at the function over here on the right, we can see where this is going to be in the equation inside the parentheses. So if I look at this +1, this x plus 1 inside the parentheses, this is what's going to tell me that I'm going to shift my graph left by 1 unit. Now, intuitively, as you look at this, you may say, well, why don't we go to the right? Anytime we're with the x on the inside of the parentheses of a logarithm, we go opposite of what the sign tells us to do. So in this case, we're going to go left one value. So our vertical asymptote will be at the line x equals -1. So that line is going to create a boundary for our graph. Now, the second thing we want to be able to look at is what we call the base of the logarithm. So in this case, our base is a value of 1/3. And since we have a base of 1/3 and our value of 1/3 is less than 1, we can say that this is logarithmic decay. Now, if you look at the graph over on the left, we can see that it is getting smaller as the values of x go from left to right. If that value of 1/3 had been greater than 1, this would be an opposite graph. Instead of going down to the right, it would instead go up to the right. Another thing that could potentially change that is this value of 2 out front. If this 2 had been a -2, we would see the graph going the opposite way, and I'll show you that on the graph over here. We can see that with a -2, the graph in purple here goes up to the right, whereas with a +2, that graph goes down to the right because of the log decay. Let's take a look at a second function to see if we understand how this works. So this function here is the log base 3 of x minus 2. So again, the first thing we want to be able to look at is our vertical asymptote over here. So our vertical asymptote, since it's an x minus 2, we're going to say is at the line x equals +2. Because again, we want to go opposite of what the sign tells us when it's with the x value. The next thing we want to look at is our base. In this case, it's a base of 3. That's going to tell us that we are growing. So this is log growth. So we have a vertical line that creates a boundary where x is 2. We have log growth. So if we come over here and look at what this graph is going to look like, where x is 2, it gets very, very vertical and creates that boundary. And because of the base of 3, it's log growth. Now, if we would have had a negative number in front of this log, that would again flip the graph over and go down to the right and kind of act like log decay. But with it being a positive log and a base of 3, we can see that it continues to be growth.